Hello and welcome to AI and Drug Discovery. We are here to discuss AI-driven drug discovery target identification. My name is Sukant Khurana. Welcome, listeners. In today's episode of AI-driven drug target identification, I'm Dr. Sukant and I'm joined by Bikram, a rising star in computational biology. Bikram, thanks for being here.
Thrilled to be here, Dr. Sukant. It's such an honor to be doing this podcast with you. Let's dive into this exciting topic.
Absolutely. Drug target identification is critical in drug discovery. Traditionally, very slow process, years of lab work sifting through pathways. How is AI changing that landscape?
I believe it's a game changer. AI is speeding things up dramatically with machine learning predicting targets faster than ever. Take GNN graphical neural networks, for example. They are amazing for modeling protein interactions. You input molecular structures, binding affinities, and the model flags druggable proteins. I read about a study using GNNs for kinase targets in cancer, boosting hit rates by 30% over traditional methods. So that is huge.
Impressive numbers. Kinases can be tough with off-target effects. How does
Mhm.
AI address specificity?
That's a great point, actually. Specificity is tricky, but AI shines with multi-omics integration. Instead of just gene expression, you combine transcriptomics, epigenomics, metabolomics. Deep learning, like transformers, weighs these layers to pick targets with minimal crosstalk.
Well, that's very clever. Data quality must be a challenge now. Garbage in, garbage out, right?
Right. Totally agree to that. Clean data is everything. Public databases like Campbell or proprietary pharma sets. Public data has been often noisy and proprietary data is siloed.
Noise is a constant battle. Another concern I've heard is interpretability. If
Right.
AI predicts a target, how do we trust the why behind it?
That's a hot issue. Especially for regulators, you need to know why a model picks a target. Explainable AI like sharp values breaks it down, showing if a protein's binding pocket or expression level drove the prediction. I'm also excited about hybrid models pairing AI with mechanistic simulations. You get data driven prediction plus biological logic.
Hybrid sounds promising, computationally intensive, I imagine.
Yeah, they can be heavy, but the field is fast moving. So hardware is also catching up.
Speaking of progress, what's an area where AI is making a unique impact, say for underserved diseases?
I will say it is rare diseases. Traditional approaches often skip them. Small cohorts, scarce data. AI mines genomic databases for shared pathways across diseases. I saw a case where reinforcement learning identified a repurposed target for a rare neurodegenerative disorder, analyzing 10,000 patients' genomes in a day. Life changing stuff.
That's remarkable. Where do you see the next big leap in this space?
I'm talk about dynamic models, think federated learning, where AI trains on decentralized database without sharing sensitive data. It's big for privacy and collaboration. Imagine models updating in real time as new data comes in.
Fascinating vision. One worry though. Does the
Mhm.
override ever lead teams to skip validation and trust AI too blindly?
Oh, definitely. AI is powerful, but it's not magic. I've seen projects derail when people rush past wet lab validation. The sweet spot is iterative, AI predict, lab test, then you refine the model. It's a tech biology dialogue, I will say.
Any final thoughts on AI-driven target identification is headed?
It's writing the playbook, faster, smarter discovery. I'm just excited to keep pushing the boundaries.
Well, that's the spirit. Thanks, Vikram, for fascinating discussion, and thank you, listeners, for joining us. Until the next time, adios.